Good morning. So today our group gonna present about beam analysis and design. So this is our floor design and beam design. So we're gonna discuss how we get this design. Next. This is the design for each floor. So first we do modeling in ETAP. So this is like the first floor, this is second floor, and this is the roof. Now my friend Chirag will
So,
continue.
um, according to the Thai code, the live load for the roof is 100 and the unit is given right here. Similarly, as we talk about the first floor live load, this is the live load and it's 6,000. And similarly for like the superimposed dead loads for the ceramic tiles, the value according to the code is 120. So as we have selected a wall, and the wall's thickness is around 110 and 200, and the height of the wall is 3.5 meter and 3 meter. So according to that, we've got we've got uh we've got around 0.62 ton. So after we do this is for the first floor, and similarly we have done for like the ground floor as well. And this is the super imposed dead loads for ground floor, as you can see. And this is for the walls. Now this is our overall design. As you can see here, this is like a 3D view of our design according to the different loads. As you can see here, the load of the walls in yeah in every direction where there is war. And like after we do that, we
So,
run the analysis in our software ETAB, and then we get the moment. So like these are the moments after we run the design in the software, as you can see here. The, and this is for the ground floor moment. Similarly, this is for the
yeah.
shear force, and this is in ton.
So now, after we run the chat design from the E tab and then we get the volume from the last one, now we're gonna use that to find the ground floor shear. The for the unit is in ton unit. After that, we're gonna move on into the first row movement, and the unit is in ton meter unit. As we can see that the volume is all over there. And now after that, we're gonna move on into the first floor shear. The unit right now is in ton unit. So there is a unit all in the plan here, so we can see each one here. And then for the roof span movement, it's also in ton meter for in ton meter unit, and the unit is corresponding to the picture you see here. Now move on to the next one. So the last one is the roof floor shear. The unit is in ton unit, and the volume is like is in the picture that we can see here, each one over there. So now we move on to the last calculation part.
After this, like we need to select different kind of material that we use to design our beam. So according to our design, the properties of our material that we use is this, and like the it has like different values, different strength, elasticity. So after we do the design, we check it with positive bending moment, negative bending moment, and different shear force. As you can see, like the value that we have got uh the value that we have got uh is okay with the standard value that we check to for like each values. For example, we can see here we have mentioned here, okay, so this confirms that our everything is correct, and so we can proceed with our design. If the value was not corresponding to the was not able to compare with the standard value, and was smaller or greater than the value that uh greater or smaller than the standard value, then we need to select the material again. But as our values are okay compared with the standard values, so we can use this to design. For example, as you can see here, like we use a rebar of diameter 16 mm, and this as we calculated the spacing and everything, then we use only 4 bars. So this is this part is mentioned here at the first slide. Let me show. Mm, as you can see here, like we use like for the top steel we use like 3 rebars of a 3 db 16 bars, and for the strips we use a round bar of 9 mm at 110 millimeter gapping. So I think this is our presentation for today. uh and we're really sorry that we needed to do in uh online, because like we had our problems. So this is our group members to Sapon Prasad, Chirag and Raitle. And sorry for the inconvenience, and thank you for our presentation.